And let's start by taking a look at Caesar Cipher. So I'm going to make sure I clone it. Well, first I got to check out my fork. I know I've already forked it. Now I'm going to clone it. All right, does anyone have any preference on whether we tackle this one in JavaScript or Python?
JavaScript, please.
Okay. So we take a look at Caesar. So here's caesarcipher.js. We have a spec file that's just, again, as usual, we have it right here. Let's take a look at the README. So Caesar Cipher, also known as Caesar's Cipher, the shift cipher, Caesar's code, or Caesar's shift, it's one of the simplest, most widely known encryption techniques. So it's not very secure, but it makes for a good coding problem. So the idea is that it takes a message and a shift number, and that number determines how many places along the alphabet you replace it with. So for the example they have here is if you place what a string and the shift is 5, you'd get this right here. And considerations, it says, is we'll need to remember how to convert a string into a number. Don't forget to wrap from Z to A. Don't forget to keep the same case. All right, so first off, we can start by converting this runner file into an actual spec file. So first off, if I want to make this jest, I need to change something with the file name, right? What is it?
_test dot test.
Yep. So I need to rename this to caesarcipher.test.js. And like that, it gives me a little change of icon here to let me know that it's now a test file. All right. And then what's the next step in order to get jest working?
You have to do npm init.
And there's a shortcut so I don't have to keep on entering past all those things, right? Does anyone remember what that is?
-- yes.
Or -y.
Or -y, yes. Both of those will work. So now I have a package.json. I can just change this one to jest. Might as well. I don't remember if I have jest installed globally, so I'll just install it right now to be double sure. Never hurts to install again. All right, so while that's going on, we can still start setting up our actual test file here to make it more like what we want it to. Comment all these out. And let's put up some tests here. So we can say test converts a string with a negative shift, that's what we'd call it. Then pass it an anonymous function. And we'd expect it'd be CS, and we're passing it, get out of here, passing it, boy, what a string. And -5, and I forgot to put that in quotes. There we go. Dot to be, let's copy this. Let's test another few of them. Nope, no, not that. Converts with positive shift. Oh, cs.caesar cipher is what we want to say. Dot to be. And for now, we can just leave it at these. So one thing I like about writing these spec files is it already tells me a few things about how I'm going to be approaching this problem. So for example, looking at this second solution here, I have hello Zach168, yes here, converts it to this. So what does anyone notice anything about what changes, and more importantly, what doesn't change in between these two strings?
Capitalization and punctuation stay the same.
Yes, the capitalization and punctuation stay the same. So we need to make sure that when we're converting this, that any letters that are capitals stay capitals, and that we don't shift any punctuation marks. One other thing, is anyone noticing it?
Numbers as well.
Yep, numbers also stay the same. So this already tells me, before we even start writing our pseudocode, that when we're going through this problem, we can safely ignore anything that is not an alphabetical character. All right, so in the meantime, I'm going to change this one up so exports equals Caesar cipher. That's better. All right, now let's start pseudocoding. So first off, we have, define Caesar cipher function that takes a string and a shift amount. And we can kind of cost that off right here by saying, string shift. There we go. That's all taken care of. All right. So now thinking about this, in order to decide, all right, we know we're going to be shifting each letter our either up or left or right through the alphabet. And so of course we as human beings know what the alphabet is, but we need does our program know what the alphabet is right now? Nope. So we're going to have to decide, all right, this thing needs to understand, we need to tell this thing what order letters are in. So we can say define alphabet, which equals, I will say A through Z. Right. And then maybe we want to create an empty string to be our answer string. So like, define return string as empty string. All right, so now we have an alphabet and we have an empty string that we can put that we can return at the end of this function. So now if we want to, change something in this string or create something new in this string based on what each character is, what does that tell us? What are we going to have to do with this string?
Slice, replace.
Loop.
I'm sorry?
Loop through
You
it.
have to loop through it, and you're gonna have to slice and replace possibly.
Mm-hmm. Yeah, so we're definitely going to have to iterate through the string. And so you said we could slice and replace things. So that is one way of approaching it. The other way of approaching it is kind of what I've kind of already started out, which is creating an empty string to return. And the reason I've decided to take this particular approach is I want this function to be what's called pure, meaning the function takes in these arguments and it's going to spit out a new value without changing the original string. And the reason we do this in JavaScript in particular, it's kind of a design philosophy saying that a function should only return one value and shouldn't have any other side effects, which includes changing things that it was given. And if you don't approach it this way, it's not a problem. But this is a design philosophy I want to kind of embrace right now so that I continue to do so later, because I think it's a good coding practice. But yes, we could replace or we could create a new thing. Both will work. All right. So now we're iterating through the string. And now what do we want to do? For each character, what do we want to check?
If it's A through Z, or if it's a punctuation mark or whatever.
Mm-hmm.
Or if it exists inside of the list, or however we're going to define the alphabet.
Yep. So we're going to check if it's a letter or if it's not a letter. Those are our two things that we really need to care about. So let's start with the easier one. What do we do if it's not? So if it's not a letter, if character is not letter, what do we do?
Leave it alone.
Yeah, leave it alone or add it to the return string, unchanged. All right, then we have our else. If the character is a letter, then we need to do what with it? So we need to shift it, yes. So so shift letter by shift amount. And to do that, we're going to need to know something from our alphabet list, right? We're going to need to know what the index number of this alphabet list is. So in order to do that, I'm going to say find index number of letter in alphabet. And then we'll have a new index number, which is equals index plus shift amount. Now, the tricky part comes here. What happens if if our shift amount is 2, but the letter is Z? What happens if we just add 2 to that and then try to get the letter 2 after Z?
You get if you're lowercase, depending on how you're referencing it. If you use ASCII values, then it would potentially go into some other version, so capital to lowercase or lowercase to capital. So to avoid it, we pretty much did a modulus. Instead of doing mod 2, we did mod 26, because there's 26 letters in the alphabet.
Yeah. So if we just add it to the number and then try to get it, best case scenario, we get something, we get a letter we didn't want. Worst case scenario, we get an out of bounds error and the whole thing breaks. And so we could use modulus for that to say, all right, get the modulus of that divided by 26. Am I understanding you right?
Yes, that's correct.
Yeah. So if new index is greater than 25 in this case, you'd say new index equals modulus 26. And what if our shift amount is -1 and it's A? Would we do the same thing? Because then we'd be at index number -1, which we know from experience with JavaScript doesn't work.
I accounted for that by doing the same thing, modulus 26, and then you add an additional 26 to that value. So it's always positive.
New index equals modulus 26 plus 26?
Right.
Okay.
Yeah, alternatively, instead of trying to do the testing if it's over 25, because whether it's positive or negative, it's in the range you add 26 to it. It's basically when you're using the modulus afterwards, you're not really adding anything. It's the same thing as like multiplying by 1. So instead of testing if the new index is greater than 25, after we calculate the new index, after the shift amount, or even on line 10 there, or step 10, we could actually add 26 to it. Then all we have to do is adjust with modulus 26 at the very end. So you'll have the new index plus or minus the shift value plus 26, and then take all of that modulus 26, and you'll have your adjusted correct index all in one step. But that way you don't have to test if it's a negative shift or a positive shift, if it's above 25 on the index scale, you know. So it's all kind of pre-built in by 1.
So just checking, so you found a formula that would essentially give you the correct index number regardless of whether it was 25 over 25 or below 0.
Yes.
Nice. All right, that's good. All right, either way, then we want to add, would be alphabet new index to return string, and then return the return string. All right. Any questions about this pseudocode before we start actually coding it out? Is all making sense so far?
No, I did. The thing I told you, I think that's wrong. When you add the 26, because then it'll be over again. You need to wrap again one more time.
Yeah. So one thing so another way of approaching it, which means you don't have to use modulus in this case, is we can also just say if the new index is over 25, we can also say new index minus equals 26, and that'll give us the same effect. And same thing here, if it's under 0, we just add 26 to the value, and that'll give you that wrapping effect as well. So there are many ways to approach that. This is just the one that makes the most sense to me because I can just, I understand subtraction and addition much better than I do modulus. But that's just me. All right, so I'm going to start this off. So first off, I'm going to say let alphabet equal. Now I don't believe JavaScript has a built-in way to just say, give me all the lowercase letters that I know of. Has anyone encountered that? Because that would be a big help, because I don't want to have to type out A, B, C, D all the way down to Z. Nope, okay.
I guess you might be able to do it in the ASCII table and convert back. You'd still have to step through it, but
do a regex.
Could also use regex.
Can you use regex to assign things or just to check things?
No, we haven't really done regex in JavaScript in this program yet. So let's see, regex JavaScript methods. See if there's anything here that'll help us out. Here's a guide on the Mozilla page. So it looks like we can do that. Provide compilation of the regular expression when the script is loaded. So they have A, B plus C. So let's try this out in a node shell. So I do let alphabet equal, and this would be well, that gives us the regex expression, but it doesn't actually give us the letters. So that gives us the pattern. I don't know if it allows us to actually resolve it from a pattern to a string. Let's see. Okay, here's some methods. So there's exec test match returns an array of all the matches. Okay, so doesn't look like there's just a method that says, what does exec do? Executes for a match, and it searches for a match in a string. Okay, so in this case, I don't believe that we have a method that'll just automatically give us all the letters. And we could use regex, but I've already done my pseudocode without it, so I'm going to continue with it. All right, I'm also going to define my return string. All right, and then we can start looping. 0I is less than string, string.length, I++.
No, on the pseudocode, did we miss the capitalization check?
You're right, we did. Yeah, so we should, right, we did forget one thing. We forgot to account for capital letters. So I can think of an easy way to do that would be just say this would be lowercase alphabet equals that, and then we can define uppercase alphabet for the larger ones. That's one way to do it, right? Did anyone take a different approach?
Well, you could just, if the current character is equal to current character to uppercase, then you know it's uppercase, and just check for its current state.
Mm-hmm. Yeah, so we could also make sure that essentially compare every letter to the lowercase alphabet and then convert it back to uppercase if it is uppercase. That's another way of doing it. In this case, I think I'm going to stick with this plan just because we can just do that. And just to save time, I could also say, so change this one to lower alphabet, and then let upper alphabet equal it's probably not the most efficient way of doing it. It's probably more efficient to actually type it out, but I don't feel like it. All right, so now we can loop through our string. And first off, I'll just say, let char equal string I. Seeing something in the chat. Import string.ascii lowercase.
There's a module for that.
Oh, wonderful.
That sounds like Python, doesn't it?
Let's try it out. It says right here, import can only be used in TypeScript files.
If there's a module or library, wouldn't we have to npm install it in our particular folder and then just include it as a require up at the top?
Let's take a look. So not all libraries need to be npm installed, depending if it's built into JavaScript or not. I don't believe we have to in this case. It doesn't look like there. Yeah, I think that was we were getting a little bit confused with Python's string library. Well, now we're here. Like, is there one that gives us like all the ASCII characters or anything like that? That would be cool if it did, but somehow I doubt it. But let's keep this page open because it seems like there's probably a few methods here that would be useful.
I found one, Noah, if you want to use it, but it's up to you. Just npm alphabet.
Oh, cool. How about we take a look at that after we do our thing here, just so that we can not go down rabbit holes of installing things that I don't know how to use yet. So let's solve this without a library, and then we can add the library afterwards to, what's the word? Optimize it. Thank you. All right. So we've gotten our char, which is equal to string I. Then we need to see, all right, I'm going to check first if it's in the lowercase alphabet, then if it's in the uppercase alphabet. So if I could do something like if lower alphabet dot, what's a method to detect if this substring is in our larger string? In Python, we could just say if char in lower alphabet, but we don't have that option with JavaScript. No, I could always look it up. So let's take a look at some of the methods. I'm sorry?
Dot includes?
Dot
Or is
includes.
that for arrays? That
Let's
must be
try it
for
out.
arrays.
Sometimes things that work for JavaScript string includes. Looks to here that there is a JavaScript string includes method. So we can do, yep, we can just do dot includes. So we could say if lower alphabet dot includes char, then we need to shift it. So first off, we need to find the index number. And it looks like there's a method called index of. Let's try that. Returns up the position of the first occurrence of a specified value in a string. Oh, that's exactly what we need. So we could say let index equal lower alphabet dot char at, make sure I'm doing this right, or index of. Index of char. Then we could say let new index equal or plus equal. Oh, it'd be let new index equal index plus shift. And then we need to just do our thing about, okay, is it greater than 25 or less than 0? So if new index is greater than 25, new index minus equals 26, else if new index is less than 0, new index plus equals 26. Excuse me. All right, and then we'd say, and if all that happens, then we would say return string plus equals lower alphabet at new index. So running into this, I'm already seeing kind of a future problem that we're going to run into, because we have our lower alphabet and we have our upper alphabet. And so we're going to have to repeat this, essentially, do the exact same thing just for uppercase. And that sounds boring. So maybe we can change this to make this a method. So how about I define a new method? You could call it shift letter. And let's say this thing as an argument takes in a character. It takes in a shift amount. I'm going to call it shift amount just for things, and an alphabet. And I'm going to essentially replace all of this with, do all this with a method. So I'm going to just copy this, put it in here, fix this because it bothers me if I don't. All right, so we have index equals lower alphabet dot index up. In this case, it would just be alphabet, not lower alphabet. Then we have our new index, index plus shift. Then we do our thing here if it's greater than 25 or less than 0. And then instead of saying return string plus equals, we're just going to return alphabet with new index. All right, why is it saying, oh, I've got return. And instead of shift, we gotta make sure it's shift amount because I changed the variable there. So the reason I did that was now I can say, all right, if lower alphabet dot includes char, I can just do return string plus equals shift letter. And we're going to pass in char, shift, and lower alphabet.
Are we going to return the string, or are we just adding it onto our? Oh, okay, never mind. It's naming as a variable kind of threw me off, so I try not to use a return in a variable name. All right, thank you.
No problem. But any other questions about what I just did there? Because what I've essentially done is I've created a function just to say, all right, if it's lowercase, do this, shift it with the lower alphabet. And then I'm going to have another one that just does this for the uppercase alphabet. So I do upper alphabet. Dot includes char. Do the same thing, return string plus equals shift letter. Char, shift, upper alphabet. Is that making sense? Okay, now I'm going to put an else. So if it's anything else, return string plus equals char. We don't need to change it. And then once we've finished going through all this, then we can just return our return string. So now I can test it out. I can say node test. Uh-oh, what did I do? Module not found. Throw error, cannot find module. What did I do wrong here? I used the wrong command. I should have done npm run test. Uh-oh. Let's take a look here. What happened? Ah, okay, we have an importing error. So I have module.exports equals Caesar cipher. I always get confused with input when it comes to importing things with JavaScript, or requiring in this case. So I think I would have to do this. Let's try that. There we go. And now we have 2 tests passed. All right. Any questions about Caesar cipher? The solution making sense to everybody? Okay. In that case, let's make it a 10-minute break. So be back here at 9:23. And then we'll start with bubble sort.
Okay, Noah, I figured out a way to generate